I hope that you, like me, want more from physics than just numerical predictions. I hope you want ontological clarity, an understanding of why the laws of this world are the way they are, and not some other way. Modern physics is brilliant at answering the question how, but the ultimate question, why, remains open. To find the answer, we have to take a different path. We must derive all of physics from first principles, with no assumptions. Let's see where this road takes us. This path demands rigid discipline. It stands on three methodological pillars. Epistemic hygiene. We must reject all unnecessary assumptions. Strict relationalism. Everything must be defined only through its relationships. Zero free parameters. Nothing is to be fine-tuned. Everything must be derived. In short, nothing is assumed. Everything is derived. If we look at the history of great breakthroughs, we see the same trend. Copernicus, Newton, Maxwell, Einstein. None of them added complexity. They eliminated false separations. They unified what seemed different. And in doing so, they made our picture of the world simpler. Applying this methodology today, we immediately find the last remaining separation, the hidden assumption of all modern physics. The split between structure, the stage of spacetime, and dynamics, the energy that acts upon that stage. We have no evidence that this separation is real. We accepted it only for mathematical convenience. So what happens if we refuse to accept it? If we reject this separation, structure and dynamics inevitably become one and the same. This leads us to a single central principle that is not postulated but derived. Spacetime is equivalent to energy. But what then is energy? If it's not just the ability to do work, but the very fabric of reality? In this system, energy is a relational measure of difference. It is the guarantor of causality. It is the manifestation of change itself. So we've established that spacetime and energy are a single entity. What properties must this unified structure possess? Logic dictates three unavoidable conditions. Closure. With nothing external, the structure must be self-contained. Conservation. If it is closed, the total measure of transformation energy must be conserved. Isotropy. With no external reference points, the structure must be maximally symmetric. No preferred directions. These three constraints, closure, conservation, and isotropy, become the rigid framework for the geometry of our universe. What are the simplest geometric forms that satisfy these three strict rules? Mathematics gives a unique answer. There are only two minimal carriers for relational transformations. For a directional change, like motion, the only closed, one-dimensional form is the circle, S1. For an omnidirectional change, like a gravitational field, the simplest isotropic closed form is the sphere, S2. And this is the key. These are not space-time geometries we live in. They are relational manifolds, abstract structures that encode the laws of conservation. Let's examine the first carrier, the circle, S1. It describes kinetics, or motion. Any state on this circle can be described by a parameter, beta. What does it mean? If beta is 0, there is no relative motion. If beta is 1, you are at the maximal rate of relative change, the speed of light. Think of it like a fixed budget. The more you spend on the horizontal projection, moving through space, the less you have left for the vertical projection, your own passage of time. And notice, the vertical projection, beta y, and the gamma factor from special relativity are simply mathematical inverses. Special relativity begins to emerge on its own, just from the geometry of a circle. But this simple circle holds something far more profound. Let's project energy onto it. The vertical component is the invariant rest energy, mass. The horizontal component is momentum, the measure of displacement from rest. And the hypotenuse is the total energy of the system. The closure of the circle dictates the Pythagorean theorem. The sum of the squares of the two sides equals the square of the hypotenuse. And when we write this down for our energy projections, we get Einstein's famous relation, E² equals p² + m². This is not a law of nature that had to be postulated. It is simply the Pythagorean theorem on a relational circle. The geometry of spacetime is nothing but the shadow cast by the geometry of relations. So the geometry of the circle generated the entire kinematics of special relativity for us. What about gravity? For that, we turn to the second carrier, the sphere, S2. In analogy with motion, we describe a state in a gravitational field with the parameter kappa. If kappa is 0, there is no gravity. If kappa is 1, you are at the point of no return, the event horizon. You can think of kappa as the fraction of the speed of light needed to escape gravity at a given point. We see the same projectional structure as we did for motion. This hints at a deep symmetry. We have seen how kinetics and gravity emerge from geometry. But are they independent phenomena? No. In a relational system, they are merely two different projections of the same invariant energy. Each transformation, both kinetic and gravitational, stretches the observable quantities, but does so in a coordinated way through the same universal mechanism. And from this, another inevitable conclusion follows. Inertial and gravitational mass must be equivalent. What general relativity posits as a fundamental postulate, here, in relational geometry, emerges as a simple consequence. Not an axiom, but an identity. If these two projections, kinetic and gravitational, are parts of a single whole, there must be a strict exchange rate between them. And this rate is not an arbitrary number. It is dictated by topology itself. Simple directional motion, which we describe on the circle S1, requires 1 degree of freedom to specify it. But an omnidirectional gravitational field, described on the sphere S2, requires 2 degrees of freedom to specify a direction from its center. The ratio of their dimensions is 2 to 1. And since energy is quadratic in its manifestations, this simple topological ratio translates directly into a fundamental law of physics for all closed systems. Kappa squared equals 2 times beta squared. This is not an empirical law. It is a geometric requirement. Now we have both components, the kinetic beta and the potential kappa, and the rigid link between them. We can combine them into a single vector describing the system's total projectional budget, Q. This vector exists on a unified plane of relations. Different physical phenomena are simply points in this space. For example, a photon's orbit, the so-called photon sphere, is not some exotic location. It is simply the point where the system's total budget, Q, equals 1. Everything becomes part of a single simple geometric picture. This unified picture generates its own conservation law. The energy symmetry law. It states that any energy change seen by one observer must be perfectly balanced from the perspective of another. Nothing can be created or destroyed in a closed cycle. This simple idea of observer reciprocity has enormous consequences. It is what ensures global consistency and preserves causality. It is what forbids faster-than-light travel. The universal speed limit is not an arbitrary restriction. It is the boundary beyond which the fundamental symmetry of the universe breaks down. And here, we arrive at the most radical conclusion of our investigation. In this picture, there is no place for traditional, quote, equations of motion. A physical system does not evolve in time. Instead, there is only a closed network of algebraic relations between kappa, beta, density, and distance. The system does not move. It perpetually exists in a state of perfect balance. What we perceive as dynamics is merely the ordered succession of these balanced configurations. Causality here is not temporal, but structural. And this completely inverts our concept of time. Time does not drive change. Instead, change itself defines what we call time. Our investigation has led us to 2 relational parameters, kappa and beta, which describe gravity and motion. Now we can put it all together. The entire complex dynamics of gravity, which general relativity describes with cumbersome differential equations, is reduced here to a single, maximally simple algebraic identity. Kappa squared equals a ratio of radii, which equals a ratio of densities. Geometric curvature and energy density are not cause and effect. They are literally the same thing, written in different languages. And look at the consequence. This geometry, by its very nature, forbids singularities. Since kappa is capped at 1, energy density can never become infinite. The problem of black holes is solved not by introducing new physics, but by removing the original ontological mistake. Let's step back and look at our entire journey. We started with a simple act of epistemic hygiene, removing the unjustified separation between spacetime and energy. This single step led us, with iron necessity, to the geometry of the circle and sphere as the only possible carriers of relations. Their topology dictated the universal exchange rate between kinetics and gravity, and this chain of reasoning closed upon itself in the unified field equation. But what does this equation tell us? It tells us that the ratio of geometry equals the ratio of energy. In other words, space-time is equivalent to energy. Our final conclusion is exactly our starting point. The logic is sealed. It is a theoretical Ouroboros, a system that proves itself through its own internal consistency. But the ultimate question remains. Does this beautiful logical structure describe our universe? Is it physics? Let's check. The relativistic precession of Mercury's orbit? The model predicts it with an accuracy of 10 to the power of minus 10%. The complex time shift for GPS satellites, which requires combining both special and general relativity? This geometry yields the exact empirical value of 38.52 microseconds per day. Critical orbits, like the photon sphere, they emerge not from complex calculations, but as points of natural geometric symmetry within the system. Every empirical test that has ever validated general relativity also validates this simple geometry with the same or even greater precision. We began with a single principle: space-time is equivalent to energy. And it seems this one principle is enough to define the entire structure and symmetry of our reality. What you have seen are only the foundational results, the first logical consequences of relational geometry. This same methodology has already been extended to cosmology, explaining the universe without adding dark entities, and to quantum mechanics, deriving its core principles from this same geometric foundation. To explore the full scope of this research, including its predictions and interactive models, you are invited to visit the Will Relational Geometry website. The link is in the description. Thank you for following this path of reasoning.